Now, today for day 2, what we're going to do is take our slime and we're going to incorporate some different minerals in it and see if they dissolve. So, first thing we do is take off the top of the slime and pull it out of the bowl. If you didn't do this already, you might want to move, divide it into 2 and then put this in if you don't want to. Otherwise, you can go ahead and just keep adding all of it. I'm going to do, for demonstration, everything in one big blob of slime. So, we are going to try this material first. As you can see in here, here's the foam balls that we did yesterday. Those are already incorporated. Here is some very small crystals of sugar, colored blue. Here is some slightly larger sugar balls in multicolor. And then here is some large particles of marshmallows, like the Lucky Charms that you get in sugar. So let's take the small sugar crystals first. So these crystals are very small, which means they have a lot of surface area. So theoretically, if you want to make a prediction, they should dissolve into the slime pretty quickly. Let's try and see what happens. Sprinkle the sugar all the way down the length of, this may make a mess, warning. The length of your, oh boy, now we did it. The length of your slime. That's why we gave you way more than you need. Then kind of fold it over and incorporate it. It will not dissolve right away, as you can see. It's getting all over my hands. It's really not dissolving at all. But then look closer, and you can notice that the foam balls never have dissolved. They are coming right out of the foam. The sugar should be in there somewhere. And the sugar, oh, you can see it. See, if you look next to that pink ball, there is some blue material in there. That's the sugar. Now, as we keep molding this along, we'll see if the sugar dissolves. We know that it doesn't dissolve right away. We know that the foam balls do not dissolve at all. That's called insoluble. So the foam balls are insoluble in the slime. The blue sugar is still, the question is still unanswered. We can see blue sugar suspended in the slime, but we're not really sure if it's going to dissolve. So, time will tell. It doesn't dissolve real quickly. If it does, it may take quite a while. Okay, and now we're going to try the next material and make a new metamorphic mineral and see if that dissolves into the slime. Now, as you can see, we have done, so far, we have added to the slime foam balls. That was what we did the first day. We added the blue sugar, perhaps a little bit too much blue sugar, because my hands are pretty sticky. Now what we're going to add are these small sugar balls. Now here's the slime after the incorporation of the blue sugar. As you can see, it's really kind of turned into a more turquoisey aqua shade. It used to be that kind of slime green. And now it's definitely more of a sea green, kind of blue-green. So let's go ahead and try the sugar balls. Now, as far as did it dissolve or not, we have only waited about 5 minutes since we added the sugar, so I'm not sure if it's dissolved, but it does look like it's changed color. So I think there is some dissolution going on. And that would be because the blue sugar is much more smaller, and so it's got more surface area. So it's going to dissolve a little bit quicker. Now we're going to add kind of a medium size. They're somewhere in between the foam balls and the blue sugar. I think that's enough. Remember, we gave you way more than you need, so you can do this many times if you want. And then I'm going to try to fold it up this way because last time with the sugar, it was like all over. So I'm going to roll it up like a fruit roll up, and then I'm going to start squishing. And as you can see, there they are, they're in there. And I note some dissolution. Do you see it? It's colors that are moving out. They're kind of like stretched. Okay, let me see if I can hold it still. Did you get that? The colors are stretched. If you look at the green, the red, the orange, they're stretched on either side of the ball. And so they are starting to dissolve into the slime. And they're doing that just like that metaconglomerate that was stretching that we saw the other day. They're turning into more of an oval shape. And they're doing that because they're trying to move to areas of less pressure. Let's try to fold this up again like a fruit roll up and try it should we try it the other way? Let's do it. Okay, there's the foam ball falling out. As you can see, this was insoluble and it still is. It is not dissolving slowly, it's not dissolving at all. The blue sugar dissolved already, made it aqua, and now we're seeing these medium-sized sugar balls are beginning to dissolve as well. It may be the end of that interesting color, but right now it's kind of interesting. It's a multicolor effect. And as you can see, that is dissolving into the slime. Now, what this is called is, you can think of this in terms of contact metamorphism. And we're going to get into that tomorrow when we do the differences in slime due to temperature. But for right now, just note that. So be sure, like again, try to take pictures of your slime before and after, or make sketches and color them with colored pencils, because these observations are pretty cool and they will help you understand all the different ways that rocks can metamorphose. So be sure you're taking some photographs or videos or something like that, or just sketch it and color it with colored pencils. So that is all for that. Now next, we're going to try to incorporate even bigger material. Okay, well, now we have moved up to trying to do an experiment with the largest materials that we have. Now again, just to quickly review, we did the foam balls, they're in there. We did the small blue sugar, that changed the color and it's turquoise now. We did the medium sugar balls, and those kind of made like a rainbow effect, and they made a stretched pebble as they dissolved with pressure. Now we're going to add this. Now let's take a minute and kind of see what our slime looks like. It's been about 5 minutes since we added the medium sugar balls, and it's already looking a lot less translucent, a lot more opaque. There's a lot of dissolution going on with those medium-sized sugar balls, and it's sort of not quite as pretty as maybe it was before, but you know, that's all an opinion. So you might think this is the coolest slime you ever saw. Let's go ahead and try the marshmallows. Okay, these are awfully big, so I'm going to stick them in like one by one. I'm going to try, we carefully gave you one of kind of each color. There's 2 pinks, an orange, a blue, and a green, and a purple. So I'm just going to do like There, now they're all out. Try to stick them all in here. Why not? Roll it up like fruit roll up so that they don't just go flying out all over. Ew, look at this. There they are. There's a nice little swirl on that side. Let's see what happens. They don't dissolve right away. As you can see, that pink one could like easily fall right out. Let's see what happens as we try to let it stretch. It is definitely less stretchy now that there's a whole bunch of junk in it. And this is pretty much it. We're not going to add anything more, but you've got a lot of stuff in your slime now, and it is not as slimy as it used to be. It doesn't deform under pressure as much. It's turning like completely solid now, whereas before it was kind of this weird plasma type material. Okay, so there's the marshmallows somewhere in there. You can kind of just barely see them. Now what we're going to do is we're going to, you can mush it around a little bit. There's one. You almost like get it to come out of the slime. You can see it in there. Now what we're going to do with this is we're going to kind of put this back in here, and we're going to just let things happen and let things dissolve and see what we can observe with this as time goes on. So there you go. You have now incorporated everything into your slime, and see if you can make new metamorphic minerals by dissolution. Welcome to looking at what we did with the slime and relating that to metamorphic rocks. So this little short video here kind of should remind you of maybe the foam balls moving around in the slime. What we did was we looked at how metamorphic minerals and rocks form new minerals, usually with the help of chemically active fluids, and what those, which is usually water, and what those chemically active fluids do is they create chemical reactions. So let's look at chemically active fluids. They get the reactions going, and so it's that interaction between the fluid and the minerals, like the slime, and it's the fluid that's in the slime, and that's actually, interestingly enough, not water. If you remember back to making the slime in that video, we added alcohol and borax, and so there could be some water in there in the solution, but it's the majority of alcohol that's in there that's making that chemically active fluid, and that's reacting with the sugar balls and the sugar, and it is making the sugar dissolve and possibly new minerals to form. So as we go through this, you can go ahead and keep kind of mushing your slime around, or just looking at it and taking observations to see if those minerals start to dissolve, those the sugar, the marshmallows, and the sugar. So the new metamorphic minerals that form are limited by what is already there. So for example, what's in sugar is things like carbon, hydrogen, oxygen. We can't make gold, for example, because there isn't any gold in sugar. So you have to use what's already there. The existing atoms is basically what you've got, and overall the number of atoms don't change. So what happens is the existing atoms just rearrange themselves, usually to try to get out of the way of the pressure and get a little bit more relief from the pressure, and then that helps them, like the stretched pebbles, that helps them kind of dissolve and then form new minerals. So here's some examples of some attractive kind of minerals that might form. So this forms from the rearrangement of the metamorphic minerals, such as ruby, for example. This is a ruby in marble,
And this is an example. You're going to see one of these rubies in your beads. Here is sapphire. This is also going to be one of your beads. In fact, you're going to have 7 different sapphire beads. They're little, but they're blue, and that's another mineral that's often found with metamorphic rocks. Sapphire and ruby, in fact, are the chemical formula aluminum and oxygen. So there's 3 oxygen and 2 aluminum. That's what those little numbers mean. And so they formed in metamorphic solutions with the help of chemically active fluids. But what they had for starting elements was aluminum and oxygen. So it just recombined and formed sapphire. So an interesting fact is that both ruby and sapphire are the mineral called corundum. So ruby and sapphire are gemstone names. The mineral that they both are is called corundum, and you use corundum a lot whenever you use an emery board. That's corundum, and that's harder than your fingernail, and so that's why emery boards will smooth off your fingernails. And finally, here is a metamorphic rock of this former seafloor. So this is kind of interesting in that you have the chemically active fluids, of course, in seawater. You've got lots of that moving around. And so that made this mineral, which you don't have a bead of this, but this is called serpentine. And so it kind of has a really interesting metamorphic kind of seafloor look to it. And so I put that on at the end. So hopefully you're making some observations with what's going on with your slime. Remember to sketch that or take a picture of it or whatever you want to do. And now we're going to look at day 3 and how temperature changes metamorphic rocks. So enjoy.